Hello all, and welcome to the Global Food Security Challenges webinar, hosted by the University of Arizona College of Engineering and co-sponsored by the World Academy of Sciences and the Inter-Academy Partnership. I am Sherry Murray, Professor of Physics and Deputy Director for Research at Biosphere 2 here at the UA, and one of the 6 co-chairs of the Inter-Academy Partnership. I'm pleased to be the event chair for 2 UA Science, Health, and Engineering Policy and Diplomacy webinars this week. This one today on global food security challenges, and the one on Friday presenting some practical solutions. The UN Secretary General has called for a UN Food Systems Summit in September of this year. In this webinar, we will hear about the goals of the summit and some of the activities leading up to it from Mohammed Hassan, who among his many other leadership roles is co-chair of the summit scientific group. The summit reflects a growing recognition that our food systems and the policies that manage to feed Earth's growing population in the 20th century will not work any longer and are damaging the environment. Food systems are a major cause of degradation of soil, water and air quality, biodiversity loss, and climate change. Current food systems are inequitable. There is growing obesity as well as growing hunger and malnutrition, worsened by the COVID-19 pandemic, highlighting how fragile our food systems are. Current food systems are not providing affordable, adequate nutrition and healthy diets to 3 billion people right now. As the global population is projected to increase by 2 or 3 billion people more in only a few decades, and adequate nutrition underlies attaining all of the Sustainable Development Goals. We cannot meet the Agenda 2030 goals without a major transformation of our food systems. Food systems exist at local, national, regional, and global scales. Locally, they are extremely diverse. They must be considered holistically as systems of inputs to production, aggregation, processing, distribution, consumption, and disposal as loss or waste of food products that originate from agriculture, forestry, fisheries, and food industries, as well as the broader economic, societal, and natural environments in which they're embedded. The Inter-Academy Partnership, or IAP, is a partnership of 144 national science, engineering, and medical academies around the world that produces studies of relevance to global policy and advice to governments on national and global scales. The IAP produced 4 major reports in 2018 on challenges to regional food systems in Asia, Europe, Africa, and the Americas, along with a global report. The other panelists in this webinar, Robin Fears, Elizabeth Hodson, and Cheryl Hendricks, are some of the leading authors of that initial IAP study, along with Mohammed, who have been rather busy of late providing updates to the original study as input to the UN Food Summit. Elizabeth and Cheryl are also members of the Food Summit Scientific Group. I look forward to the panel, but before we get started, I'd like to hand the microphone over to David Hahn, Dean of the College of Engineering, for his welcome.
Thank you, Cherry, for sharing some really useful context to this event. I'm David Hahn, the Craig M. Birch Dean of the College of Engineering. It's a pleasure to also welcome you to the first of 2 panel discussions this week in our Global Food Security Challenges and Solutions webinar series. I'm really excited to help open today's session on global food security. As I've shared with many, our College of Engineering is embarking on a multi-year expansion with the goal of doubling our current enrollment And that growth is really driven by the need to increase the nation's STEM workforce, fueling Arizona's and actually the nation's and the world's economy. When I talk to high school students about science and engineering careers, I always talk about the big societal problems that we need them to help us solve. And at the top of my list is always ensuring a safe, plentiful, and affordable food and water supply to a growing world's population. Notably so in times of more extreme climate events, such as the current severe drought in the United States Southwest. So I'm really glad to see University of Arizona scientists and engineers coming together to lead both research and, importantly, to lead these types of discussions. I also want to mention that we plan to have some additional webinars in this series in the fall. It's now my pleasure to introduce your moderator for this morning's session, Professor Jim Beiser of the University of Arizona School of Natural Resources and the Environment and co-founding director of the Arizona Institute for Resilience. Jim's held many roles during his career, including director for climate and social interactions at NOAA, chairman of the board of directors of the National Council for Science and the Environment, and director for strategic institutional transformation at Arizona State University prior to joining the University of Arizona. We look forward to a very lively and informative discussion today. I'm glad you're here with us. Jim, I'll turn it over to you.
Thank you very much, Dean Hahn. It is indeed a huge pleasure of mine to serve as moderator. First of all, greetings from the University of Arizona and very warm Tucson here in the United States of America. And as Dean Hahn said, my name is Jim Beiser. And I just 1 minute about the Arizona Institutes for Resilience. It's a new university-wide institute, just a year old. It's a constellation of 11 previously independent units at the university that has been created to create knowledge and to educate future leaders with integrated interdisciplinary science-based solutions aimed at increasing resilience of our social, economic, and biological systems to shocks, especially as related to global environmental and climate change. And this, I will add, includes, of course, food security. So welcome to the Global Food Security Challenges session. Our 4 esteemed panelists today come to us from all over the globe to talk about this critically important topic of great concern to all of us. Dr. Mohammed Hassan joins us from the Sudan, Dr. Robin Fears from the United Kingdom, Dr. Elizabeth Hudson de Jaramillo from Colombia, and Dr. Cheryl Hendricks from South Africa, and you, the participants from many, many other countries as well. During this session, we'll focus on the global food security challenges. On Friday, the 25th, at this same time, the second of the sessions in our webinar will focus on the solutions. So please plan to join us for that webinar. The general format today is that we will hear from each panelist for approximately 15 minutes, presented in the order I just introduced them, followed by a question and answer session where you will have the opportunity to interact with the speakers. The one exception to this is that we will provide time for our first speaker, Dr. Mohammed Hassan, who is joining us from the Sudan, to address your questions immediately following his talk. This in case internet outages toward the end of our webinar prevent him from participating. We've received some questions via the web form, which we hope to get to. Today is your chance to interact with these globally renowned experts, so please don't be shy and add your questions in the chat. If your question is directed at a particular panelist, please indicate so. Unfortunately, it is very unlikely we will get to all of your questions, but we will do our very best. So now to our panel. The bios for all the speakers today and Friday are on the website where you registered for this event. In the interest of time, I won't read those, but simply will connect a name with a title and voice for those of you who are not joining us by video. Our first speaker, Dr. Mohammed Hassan, was founding executive director of what was then named the Third World Academy of Sciences, or TWAS, and is currently president of what TWAS became, the World Academy of Sciences. He is also president of the African Academy of Sciences and serves as vice chair of the scientific group of the UN Food Systems Summit. I will note that today, as Cherry mentioned, we have 3 of our panelists that were on that scientific group. He will talk to us today about challenges and opportunities related to the transformation of food systems necessary for human survival on this planet. Dr. Hassan.
Thank you. Thank you very much, Jim. All right. Thanks again, and it's really a pleasure to join you. I hope things go well and the power system doesn't fail us. So I will talk about 3 issues here. I will speak about a few challenges facing food systems sustainability, and then a number of opportunities. And then I spend most of my time talking about the Food System Summit, the FSS. So the challenges, I just pick 4 challenges that I'm sure you know very well. Poverty and hunger. 690 million people live below poverty line. And then malnutrition, the combination of undernourishment and micronutrients deficiency and obesity, where we have 3 billion people cannot afford healthy diet, and 2 billion people have micronutrient deficiency. Climate change, which is a real issue these days. Food systems contribute 30% of greenhouse gas emissions. And at the same time, climate change impact agriculture through extreme weather events. Biodiversity, where 75% of deforestation is caused by food systems practices, and half to 1 million species in marine biodiversity are threatened. And 70% of fresh water is used for irrigation, and quite a bit of it is really wasted. So we need to find a way of at least reducing the cost of fresh water to irrigation. The opportunities, and there are many, but I really would like to focus here on the opportunities provided by frontier science, technology, and innovation. And these are the technologies that are going to be highlighted very visibly at the Food System Summit. So I have here listed 4 such frontier technologies: biotechnologies and genomics, ICTs and digital technologies, nanotechnologies, renewable energy technologies. And there are numerous examples on how these technologies can transform food systems in all countries. And I'll just give you a few of these examples. Agricultural biotechnology, for example, has enormous benefits. It provides pest-resistant, drought-resistant, and higher crops yields. It reduces the use of insecticides, increasing nutritional value and vitamin level of crops, domestication of indigenous and underutilized food crops also can be accelerated by agricultural biotechnology. And of course, the GMOs, they still is a controversial issue, despite the fact that science has really shown a number of times that there's no harm in using GMOs. On the contrary, it really benefits quite a lot of agricultural systems or food systems. The good news is that a number of developing countries are now moving in the direction of producing GMOs. And in fact, if you look at the list of the top producers of GMOs or GM crops, you'll find that 8 out of the 10 top producers are developing countries. And we've seen very good examples of BT cotton economic success in South Africa, in Sudan, in Kenya. South Africa is also benefiting a lot from genetically modified maize. And Uganda has recently introduced new varieties of bananas that proved to be resistant to bacterial wilt that really killed quite a lot of banana plantation. Agricultural genomics, this is a new agricultural revolution which is driven by microinformatics, plant genome and sequencing and editing. It's a new breeding techniques that includes gene editing technology, especially using this CRISPR-Cas9. And it has the promise of transforming plant breeding worldwide, and helping smallholder farmers in poor countries to achieve food and nutrition security. The good thing about this new technology is that it's simple, affordable, and scalable, and considered by many experts as just a fast and modern form of conventional breeding. As you all know, the Nobel Prize in Chemistry in 2020 was awarded for work in CRISPR-Cas9. And good news is it was awarded to 2 ladies. In fact, this system of awards is totally dominated by men. So it's good to see ladies winning the Nobel Prize, especially in the field of chemistry. Now, several countries, including US, Brazil, Argentina, and Canada, are strongly supporting this new technology, precision biotechnology. But unfortunately, the EU is taking a different position. Gene-edited crops regarded there as something similar to GMOs. And they say that it should be regulated like the way GMOs are regulated. And this is quite unfortunate, quite frankly, because I think there's a convincing scientific argument that it is not really similar to GMOs. ICT and digital technologies, again, this has enormous impact in the poor countries and poor farmers, especially farmers in Africa, as you can see in the picture there. It provides these farmers with instant access to market information for informed decision on best place and time to sell their products. And satellite-based information on crop growth, moisture, and minerals accessible to farmers by mobile phone messages, another way of using these ICTs. And then drones for precision agriculture and collecting important data to support decision makers and farmers. Artificial intelligence also allowing farmers to identify areas that need irrigation, fertilization, or pesticide treatment. And a very, very good example I've recently come across is that of a teenage Ghanaian who developed an artificial intelligence app for pest control. The AI app enables rural farmers with no access to internet connectivity, and this is really the innovation, the most important innovation, to detect pest infestations before it spreads. The app uses colors and numbers, as you can see in the picture, to convey messages, making it very easy to use. The app has so far helped over 30,000 farmers reduce their crop losses and improve their harvest by almost 50% in places like Ghana, Nigeria, Togo, Burkina Faso. And the young entrepreneur was awarded $600,000 by the Zayed Sustainability Prize as the global winner for the 2020 edition of the prize. So that's really a huge success by a young entrepreneur. And that shows that these new technologies are really not difficult to pursue. So any person with intelligence can actually make a difference in these technologies. Nanotechnologies are also very important, and there are examples where they are used to improve precision farming through nanotech-based sensors and monitoring systems, and also providing efficient delivery systems for water, nutrients, and pesticides. Now, rural electrification, this is something that is so vital and important to many countries, especially the poor countries, where approximately 60% of people in developing countries have no electricity. So for them, innovation in rural electrification, like solar energy innovations, are really vital for them. And all they need is really a small amount of electricity just to enable them to operate solar powered water pumps for drinking and irrigation, and solar electricity for home, school, and communication, and solar electricity for cold storage and food preservation. So this, in my view, is really something very fundamental, especially to small-scale farmers in rural communities where most of them do not really have access to electricity. Now, let me now finally come to the UN Food System Summit. As you know, this is the first food system summit to be convened by the United Nations Secretary General. And the summit itself will be held in September 2021 in New York. But there is a pre-summit that is going to be organized in Rome in July 2021. Now, I don't really, this is really just an overview of the structure of the Food Systems Summit. It's quite a complex structure, but I don't want to go into describing each one of them. I will just confine myself to the scientific group, which is really one of the components of the structure of the Food Systems Summit. So let me just confine myself to that and hasten to say that the scientific group for the UN Food Systems Summit is a group of 29 members appointed by the Secretary General of the United Nations and selected on basis of excellence from different scientific fields and regions. And the chairman of this group is Professor Joachim von Braun, who is currently the president of the Pontifical Academy of Sciences. Now, the terms of reference of this scientific group, there are four very important terms of reference. First, the mobilizing science to support food system work plan at national, regional, and global levels through science networks and partner organizations. And the second, to engage in action tracks of food system summit with expertise from research. And I will say something about the action tracks in a minute. And the third is evidence-based assessments of action propositions. There are going to be a number of propositions generated throughout the process, but they need to be looked at, they need to be assessed based on evidence and science, drawing on diverse knowledge and peer review systems. And the fourth one is to contribute to the Food System Summit agenda and follow up after the summit. Now, the deliverables so far for the scientific group, first, the scientific group reports on key food system summit issues. And all these reports that you see here in the table are peer reviewed. You can have access to them on the website that is shown here on the top. The food system definition, concept, and applications for the UN Food System Summit, this is very, very important, and it is needed, I think, by the entire system, the food system, and the summit. Healthy diet, a definition for the United Nations Food System Summit. My colleagues later on, I'm sure they will talk about these two. And then we have reports for each of the action tracks. And there are 5 action tracks. They really form the basis of the Food System Summit. The action track 1 ensures safe and nutritious food for all. Action track 2, shift to sustainable consumption patterns. Action track 3, boost nature positive production. 4, advance equitable livelihood. And 5, build resilience to vulnerabilities, shocks, and stress. And soon to come, there's going to be a very important report from the science group. It is going to deal with the agenda. It's called the science group agenda paper. This, I think, in a few days or a week or so, we're going to see this paper. It's in its final stage. It's a very fundamental paper. Now, at the same time, partners of the scientific group, and there are many of them from the scientific community, have produced short briefs on key food system summit issues. And we expect about 40 policy briefs to be submitted. And here are 6 of them already submitted, and you can read those, you see them on the website listed, shown above. Included in those 6, as you can see, number 4 on science, technology, and innovation actions. And this policy brief is being provided by the Academies of Science. And there are several others in preparation. Now, the outlook, what is next from the scientific group? As I said, we're going to have an agenda paper for the pre-summit and summit. And this agenda paper, as I said, is very important because it identifies the science, technology, and innovation breakthroughs for food systems transformation, and also identifying and evaluating promising propositions for action. So this is one. And then the second is the United Nations Food System Summit Science Days. This is a meeting that is going to be organized by the scientific group 8-9 July 2021. And this is the announcement for it. And it has been facilitated and hosted by the FAO. Now, what we expect from this event, Science Days, is an assessment of science-based options to achieve more healthy diets, explore the frontiers of science to achieve food systems transformation, and critically assess risks, opportunities, and controversies in science and innovation for food system transformation. This is something related to issues like GMOs and so on. And then fourth is to strengthen the science policy interface to support the transition to sustainable, inclusive, and resilient food systems. Last one is very important, and I think it's going to be discussed at length during the Science Days, simply because it is our strong feeling that food system science and policy need a stronger framework to follow up and facilitate implementations of the Food System Summit propositions. At the national level, food systems research policies and strategies should be integrated into the nation's development plan. But at the global level, options to strengthen science policy interface for a sustainable food system should be explored. And this is really very important because there are so many options and scenarios. I mean, one scenario that is being considered is the science policy interface in food systems similar to, in a way, to IPCC or the IP-BEST, the climate change and the biodiversity. But what is important is to look at this interface in the way science impacting policy and policy impacting science. And the two are very, very important. So we are certainly going to see a lot of discussion in the Science Days on this issue. So finally, I just have a number of key issues that I feel are important to look at, especially from the perspective of developing countries. And the first is action to acquire, develop, deploy, and scale frontier innovations in science and technology to transform food systems in all countries. These are the technologies that I just highlighted: ICTs, digitization, artificial intelligence, and so on. The second is to attract and train the youth, including young scientists, to take food systems and farming as a career choice. Introducing courses in modern digital and agricultural technologies in education and training will attract more young people. We do not have young people entering the profession of food systems, and in particular farming. So we have at the moment 60% of farmers in developing countries over the age of 60. And 60% of Africans are under 24. And youth account for 60% of the unemployment. So there is a huge opportunity to encourage and facilitate the engagement of young people in food systems, and especially in the area of farming. And the third is the promotion of international collaboration in food system science, including joint research and training and exchange of best practices. A number of countries have really very good practices when it comes to the implementation of frontier technologies to agriculture and food systems. So these need to be shared with the others. And fourth, to strengthen links between food systems, biodiversity, and climate change. The two, as you know, are very much interlinked. And here we see an opportunity in this year, in the year 2021, because we are first going to have a food system summit in September, but that will be followed by COP15, the Biodiversity Summit in October, which will be followed by COP26 in November. So we really have to find or initiate the ways and means of somehow interfacing the findings of these three huge summits coming together in such a way. And finally, it is important also to look at investments in food systems and research development. And that has to be increased. If you look at the investment at the moment, whether it is in food systems research or in agriculture, it is very, very small. The African Union several years ago made a strong proposal that for each African country, at least 10% of the GDP should go to agriculture, and at least 1% of the 10% should go to research. So with that, I thank you very much.
Well, thank you very much, Dr. Hassan. Before we move on to the next panelist, I thought I'd just throw one question there to you. You talked about the importance of science and the science to policy interface, and yet here we are in 2021, and we have global food shortages. Scientists have been working on this for decades, and yet we still have these issues. So the question is, where does science fall short in the effort to feed the world? Are there some issues that science simply cannot solve?
Well, I have a strong feeling that science is there, and especially the frontier science, the cutting edge technology is there to help, but it has not been implemented fully, and it has not reached the majority of population worldwide. But there are countries that are fully utilizing these new technologies, and they're really making concrete transformation of their food systems. And I think it is a matter of application, finding the political will to apply, to first of all, understand, absorb, deploy these frontier technologies, and make sure that they are sustained. This, in my view, what the developing countries, and especially the low-income countries, really need at the moment. But we're not short of science. We're certainly not short of science and innovation.
That's right. Well, thank you again, Dr. Hassan, and please remain with us as long as you can.
Sure.
And we'll move on now to our next panelist. Dr. Robin Fears is Biosciences Program Director at the Inter-Academy Partnership. He's a prolific author and has served as advisor to various bodies, including academies, universities, businesses, and parliamentary groups on issues related to biomedical science and innovation. He comes to us today from the United Kingdom and will present on food security challenges, overarching global perspective from the Inter-Academy Partnership work on sustainable food systems. Dr. Fears?
Right. Thank you, Jim, for your introduction, and thank you and your colleagues very much for inviting me to this exciting event. So what I'm speaking on today is indeed a global perspective from the work of the Inter-Academy Partnership on sustainable food systems. And as Sherry Murray described a few minutes ago, the Inter-Academy Partnership, IAP, is a global network, more than 140 academies of science, engineering, and medicine. And let me just also reiterate that this particular project on food and nutrition security was organised as an interregional project with 4 working groups drawn from Africa, Asia, the Americas and Europe, really with a collective objective to identify and assess the scientific evidence that helps to inform policymaking. And as you've heard, my colleagues Elizabeth Hodgson and Cheryl Hendricks, after I'm speaking, will draw on their particular work in the Americas and Africa. My job is to provide a global perspective. And as you've already heard, there are some big global challenges for food and nutrition security. They're listed on this slide. Although much progress has been made in the past decades, and much of this progress has been based on scientific developments, the prospects for food and nutrition security are deteriorating. Over the last couple of years, we have seen increased malnutrition, and I'm using a definition of malnutrition that covers both hunger, micronutrient deficiencies, and obesity and overweight. So it's a broad definition of food and nutrition security. But by any definition, the prospects are currently deteriorating, for example, in terms of the number of hungry people worldwide. And we've seen in the last couple of years an exacerbation of this burden from climate change and more recently COVID-19. And I will come back to those points later on. But of course, many other groups worldwide have examined these challenges. And indeed, as you've heard this year, the Food Systems Summit is providing a major impetus for action by many groups. In this context, then, how can IAP help? That is, what is distinctive about IAP's work, and how can we add value to the great work of many other groups? At several points I'd emphasize from this slide. First, we work in an inclusive manner across multiple disciplines, the social sciences, as well as the biosciences and medicine and physical sciences. So we're transdisciplinary in orientation. And we integrate activity at local, regional and global levels, both in terms of assessing the scientific evidence base and in connecting with policy. So we're inclusive. So secondly, we have a focus on clarifying how the science can inform policy, provide resource for innovation and support practice. That is, we identify where there is consensus and where there are still controversies, and where those controversies can be addressed by new science. So we're looking forward to see how filling knowledge gaps can help at the science policy interface. And we're taking a global and regional approach, but very much we recognize and value diversity in agricultural systems, socioeconomic systems, and so on. In addition to these strengths of the IAP work, I will just add that we have an important complementary internal objective, that is to share the lessons of good practice between our members in order to support capacity building in some of the smaller and newer academies among our 140 academy membership. So we're strengthening ourselves as well as advising the outside world. Okay, well, as Sherry mentioned, our IAP project produced 4 regional and global reports that are shown here. And as you heard, we very much thought we should take an integrated food systems approach, that is integrating issues for agriculture and with the whole food value chain, that is all the steps from growing to consuming, indeed recycling. And in addition, to consider those issues for food systems in the wider context of the nexus between agriculture, the environment, and health. That is, how can agriculture interact with some of the issues for natural resources and the environment, not just climate change, but soil and water and so on. In consequence of taking this broad view, the material that you can see in our 5 reports is relevant to multiple SDG, Sustainable Development Goals. That is not just the focus of SDG on SDG 2 on zero hunger, but important implications for SDGs associated with health, food, land use, water use, climate action, and indeed the SDGs on innovation and partnerships. We try to map our outputs onto the different SDGs as shown here, and our outputs broadly examined issues for farming innovation, the broad food system efficiency, nutrition and public health, competition for natural resources, including land use, and the interaction with the environment. Now, there's obviously a lot of information in these 5 reports, and we've used that information over the last 2 years to catalyse continuing work, engaging broadly with the scientific community, other stakeholders and policymakers, essentially to provide the continuing resource for innovation and to inform policy and practice. So that's what we've been doing. Perhaps just to defend our approach where we have looked at interregional and global issues. Of course, we recognise that there's many differences between the regions in terms of those who are malnourished, in terms of the opportunities for food, nutrition, security and productivity. Of course, also in terms of the availability of the scientific infrastructure within and between regions. And also, indeed, there are differences in the extent that countries and regions use evidence to inform their policy making. So there's a lot of disparities, but there are some similarities. I think all countries suffer some fragmentation of a research system and the connection of research outputs to policy. Broadly, most countries are showing a similar trend in consumption. If possible, to eat more meat and dairy, and I'll come back to that, to eat more processed foods. And we all have a, to greater or lesser extent, a dependency on global trade and the interactions amongst ourselves. In addition to those regional and similarities and differences, in terms of global policy perspectives, we certainly need to emphasise that there are some things that are best addressed at a global level. For example, the delivery of international public goods that can't be satisfied even by a single country, things like food safety, trade between nations, and scientific capacity. But very much we look at science as a global activity. In terms of connecting with the policy matrix, science can help advise policy in many ways that you'll hear this morning. For example, the transformation of food systems for nutrition and sustainability, the focus of the Food Systems Summit, using science and technology to identify and define what are healthy diets, and you'll hear more about that. And having defined those healthy diets, how can we deliver those diets and monitor the impact of those diets on population health? Science has a role to play in supporting equity, in supporting accessibility of nutrition and its affordability. There are issues also for engaging with the consumer. This is not just about producing and delivering, it's also about consuming And there's a different role for the social sciences in understanding consumer behavior, informing consumer behavior, and also, of course, understanding and informing behavior of farmers and food processors and others involved in the food value chain. There's a significant agenda requiring integration of policies. You've already heard about the forthcoming major events in COP26 of the Framework Convention on Climate Change and the Convention on Biological Diversity, continuing activity on SDGs more broadly. So there's a big agenda to integrate globally, and we very much welcome the Food Systems Summit as part of that. Carrying on, just a bit of detail, we have a number of examples from our reports that you can consult for further detail. I mentioned the issues for understanding what a healthy diet is and how it can be measured and how it can be delivered. In a number of our regions, there's a significant research agenda for better using and better understanding and better using orphan crops, new food sources, functional foods, capturing traditional knowledge, developing new foods with health properties, and so on. And we might return to some of these perhaps in discussion. A very big agenda for capitalizing on biosciences. Mohammed introduced this, and I'll come back to it in a little bit more detail in a minute. As I say, also a big agenda for social sciences research to understand and influence informed behavior. In Europe and elsewhere indeed, there are very recently major advances in personalized nutrition, coupled with self-assessment and monitoring of nutritional status, and in the area of microbiomics, understanding the links between diet, the gut microbiome, disease linkages, and health. And particularly our reports from Europe and Asia focus on some of that. Okay, just bringing one other point to elaborate a little bit on what Mohammed said. One of the major opportunities in the biosciences is to capitalize on the advances made recently in genome editing, particularly CRISPR-Cas9, as Mohammed said, in order to develop improved plant varieties, more resistant to biotic and abiotic stress, or with improved nutrient content. Now, the biosciences are critically important in providing the resource to do that, but actually they're not sufficient to change for innovation and to change practice. It's also necessary to inform the farmers about the advantages of new crop varieties, and the consumer about the value of the food derived from those new breeding programs, and indeed the regulator, so that we can adopt and develop flexible and proportionate regulatory frameworks to encourage innovation. Now this slide is a simple map that describes the current situation in regulating genome-edited products. Essentially, the colors, you may not be able to read these, but red, and Europe is a good example of the red region, is regulating new genome-edited crops as if they were GMOs. And this is a point that Mohammed made. And in Europe, that is acting as an obstacle to the development and the application of new science. Dark green are those countries that are regulating, well, are not specifically regulating genome-edited products if there is no foreign DNA introduced into the product. So these are flexible regulatory systems. Light green are systems under development, for example, in India, that are expected to be equivalent to those countries that are currently dark green. That is, will not regulate if there's no foreign DNA in a product. And the, I don't know, the sort of a light brown fawn color, the regulations are under development. and in some of those cases will be expected to be more flexible. Countries in grey, we don't currently have information on the development. So the point from this map is there's a great diversity in the current and future regulations for genome editing. This is an obstacle to international trade and indeed an obstacle to capitalising on the science for the bioeconomy. And I think many of us would agree that it's important to develop more coherence worldwide in regulation, and that regulation must be evidence-based. Okay, let me come on to very briefly to an update. As you've heard, the work of IAP and its regions has contributed to the scientific group of the UN Food Systems Summit this year. We were invited to provide regional and global briefs to update the scientific group on many of the issues that we looked at earlier. These global and regional briefs are available on the UN Food Systems Summit site. And as you would expect, among the things that we've been updating are issues for regional heterogeneity, the interaction between agriculture and the environment and sustainability, and how we can strengthen the contribution of research to policy making. In addition, in our work this year on the briefs for the Food Systems Summit, we have tended to emphasize two recent issues. One is COVID-19 and its impact on food systems. And I won't say anything more now about that, but it may be a topic that we can come back to in discussion. And the other major issue is recognizing the growing impact of climate change on food systems as a potential increasing obstacle for healthy diets. As it says here, climate change itself can affect crop yield, and I'll show you that in a minute. In consequence, we need to develop climate resilient agriculture and food systems. And we also need to examine the contribution of food systems themselves to climate change through their greenhouse gas emissions. And I will, in my next couple of slides, give you a couple of examples from that. So this is a summary from CGIAR on projected changes in agriculture in response to climate change up to the year 2050. It's a meta-analysis of the literature projecting changes, and the take-home message is that much of the literature indicates that there will be increasing effects on agricultural productivity. The part of the slide on the right shows it in red where those changes are likely to be greatest. We heard in the introduction about the severe drought in southwestern US, and I think that the US will be part of those areas suffering the impact over the next few years. So this is the impact of climate change on agriculture, but the pathways are multiple. So it's a mixture of high temperature, drought, changing precipitation, changing distribution of pathogens that are affecting yield, reduced labor productivity to the high heat, increased migration that may reduce food imports. In addition, and separate from all of that, carbon dioxide itself has an effect on nutrient composition, and increasing carbon dioxide levels in the atmosphere can be expected to reduce nutrients in a number of crops, cereals, fruit and vegetables. Again, this is a collection of modeling studies projecting up to 2050 with particular impact on zinc and iron, but there are other micronutrients and protein are expected to suffer from growing levels of carbon dioxide in the atmosphere. So climate change has a number of consequences. It's important, I think we'll all agree, to develop climate resilient food systems And I mentioned previously the opportunities from the biosciences to do that. However, there's another point, and that is agriculture itself is a major contributor to greenhouse gas emissions. And it's important to mitigate this contribution if we are going to meet the Paris Agreement goals. How can we mitigate greenhouse gases from agriculture? Well, there's a number of possibilities, but very broadly, we can do two things. We can reduce food waste. In a sense, that's the easy thing to do. We currently waste 30% of the food produced. And secondly, we can promote more sustainable diets. That is, diets that will reduce the contribution of farming practices to greenhouse gases and perhaps at the same time improve human health, reducing obesity and non-communicable diseases such as diabetes. There may be many possible ways of producing sustainable, healthy diets. One way, not without controversy, is to replace much or all of the meat and dairy, particularly red meat, with plant-based diets. This will reduce greenhouse gas emissions. It will reduce land use for agriculture. It will reduce other natural resources such as water use, and at the same time would be projected to improve human health. There's an accumulating literature on how to do this. That is how to reduce meat and dairy consumption when that's excessive. However, of course, not without controversy. And of course, it's essential to protect vulnerable groups who may already be at risk, for example, from anemia. Okay, finally, this is my last slide. So from our previous IAP reports and the recent updates for the Food System Summit, IAP can bring together a range of recommendations for food systems, and some of them are shown here. Clearly taking the food systems approach to the delivery of sustainable, healthy food requires continued research in a broad area, not just in agriculture, but in environment and health, recognizing that policy boundaries are often blurred. We need to prepare for and respond to new challenges, COVID-19 and continuing climate change. We need to make the most of our research efforts around the world, across disciplines, across regions, across sectors. And that requires, has implications for capacity building. We feel that there must be institutional as well as technical innovation. And such innovation may require better coordinating international scientific advisory mechanisms. Mohammed alluded to it in his introduction. And really, in that context, and in the context of all I've been speaking about, the UN Food System Summit is a great opportunity. It's all to highlight the power of science, including fundamental research, for transforming food systems. So thank you very much for listening to me. I'd be happy to answer questions in due course, and I'll stop here.
Yeah.
Thank you.
Thank you very much, Robin, for the excellent presentation. We'll save our question, as I mentioned earlier, we're saving our question for the Q&A session at the end of our panel presentations. And I'd like to remind you, please use the Q&A chat section to submit your questions. I'm sure you have many. I know I have a lot for Robin, but hopefully you will have some too. So thanks again, Robin. We're going to move on to our third speaker. Dr. Elizabeth Hudson de Jaramillo is Professor Emeritus at the School of Sciences of the Pontificia Universidad Javeriana. It's one of the oldest and prestigious Colombian universities. She's also a member of the Inter-American Network of Academies of Sciences. Her PhD is in botany, and she currently works as an international consultant on bioeconomy, biodiversity, agrobiotechnologies, and biosafety of GMOs. So you know what kinds of questions to ask her. Dr. Hudson de Jaramillo's presentation is titled The Role of Science, Technology, and Innovation for Transforming Food Systems in Latin America and the Caribbean. Dr. Hudson de Jaramillo.
Yes, thank you very much for inviting me to participate and share some ideas of Latin America and the Caribbean food systems. Talking about food systems, sustainability and bioeconomy, I could speak forever, but don't worry, I'll make a very, very quick view of the situation in Latin America and the Caribbean, summarizing challenges, facts, and opportunities needed for the transformation of food systems in the region. For this regional perspective, we have to remember what we are talking about when we talk about Latin America and the Caribbean. It comprises from the north part of Mexico, all the Caribbean and all of these islands, to the south part of Chile and Argentina. The transformation of food systems in the Americas is critical for sustainability in all its dimensions, social, environmental, and economic within planetary boundaries. We have to remember also the crucial role of the region as the world's largest net exporter of agricultural products. So we are very important to the whole world. We export grains and oilseed as well as fruits and vegetables, coffee and sugar, among many other products. And that circular bioeconomy is the strategic area for food systems transformation in order to improve productivity and sustainable use of natural resources, and also to reduce waste. Which is the context? Remember, when we are talking about Latin America and the Caribbean, we are talking the ones that speak Spanish, which are in the yellow one, and the Portuguese part, which comprises the Iberoamerica part, which is Brazil. The main thing is that the LAC region has an exceptional, very, very rich abundance of natural resources and agrobiodiversity, and is a great world reserve of water, arable land, and forests. It makes vital contributions to the Sustainable Development Goals, including growth and trade promotion, employment and poverty reduction, food and nutrition security, ecosystem services, and climate resilience. There is also a great diversity in resources and in science and technology capacities among the whole countries, with very large difference across the sub-region, but we have many important scientific advances, like in biotechnological crops, gene editing, young entrepreneurs, the obtention of new bioproducts of high value. But also, we have high vulnerability to climate change and natural disasters, which we have been mainly seen in the Caribbean. Which is the challenge? The use of innovative agricultural technologies to produce more with less. We need an efficient use, and we have to maintain health of soils and water because they are the support for all the agricultural productivity. We have to use agriculture 4.0. My previous partners have talked about this: digitalization, automation, and artificial intelligence for efficient crop production, including weeding and pest control, precision agriculture. We have to use and improve crop diversification and rotation, permanent soil cover, and minimal soil disturbance. And we have, of course, to use biotechnologies. We have many developments in bioinputs, biofertilizers, biological control, growth promoters, among others. We have to use, apply, and improve all these studies in microbiomes, especially for agricultural production, all these soil microbiomes. We have a huge potential for sustainable production, GM crops, gene editing to obtain yield improvement, biotic and abiotic as stress management, nutritional content, many, many, many things. What is the fact? That biotechnological innovations have shown benefits for agricultural production in Latin America and the Caribbean. As a matter of fact, for example, Argentina started planting GM crops in 1996. So we have a long story of innovations and benefits. We have many documented impacts, like in Brooks and Barfoot 2020, the National Academies of Sciences in 2016, and the meta-analysis by Klomper and Quain in 2014. But we have many, many others. The other fact is that from Latin America and the Caribbean, more than 90% of the soybean and maize that are in the international markets are GM. GM has brought environmental sustainable practices like non-tillage, reduce harmful chemicals, reduce emissions, gas emissions, and also socioeconomic benefits. Nevertheless, we have to be very careful. We have to use these innovations very carefully and very wisely, because we have to include good practices and integrated crop production, such as crop rotation, because monoculture is not sustainable. And we have to face the emergence of resistance in weeds and insects. This is just a very, very small example of what we are dealing with about GM crops. 12 countries in the Americas will cultivate near 84 million hectares. Among these, this is the whole Americas, including, of course, USA and Canada. But all the other ones are from developing countries and have proven many benefits. What is the challenge? The challenge is the transformation of food systems in Latin America and the Caribbean that requires comprehensive, participatory, inclusive approaches. It's not one person or one entity who would be the change. No, it's all of us. We have to get all together for this transformation. We have to make full use of current and future scientific advances, such as biotechnologies and digital technologies, which are already transforming global agriculture, looking forward to produce more with less. That is the model, to produce more with less, more efficiently and sustainably. And that circular bioeconomy model is the one to increase efficiency and reduce residues. We have to change to healthy and sustainable consumption patterns and promote the use of residues. The circular bioeconomy, well, there is a need of integration of science and technology developments and investment opportunities to national and regional policy making, as well as communicating this potential to the public. Everyone has to know so they can use it. Policies must respond to local conditions, of course, capacities and cultures, but they also must be coordinated with global trends and consider the vulnerable groups. The innovative transition and integrated value chains require integration between scientific research and local knowledge systems, which we have to respect and use. We need bottom-up and territorial processes to define the things to do. Which are the specific opportunities based on science and technology for Latin America and the Caribbean? I would say that the first and most important one, and easy to do, is to use the huge agrobiodiversity of Latin America and the Caribbean to diversify food systems, including nutrition, underutilized or neglected indigenous crops, which are adapted to difficult conditions. So we have several advantages there. And we can increase nutritional content and to improve resilience to climate change. We have to promote aquaculture of new byproducts from biodiversity. high value added products. We have a lot of biotechnological developments to help us for plant selection and breeding for product transformation to add value, including the residues. We need to have no residues because we are using them as nature used them, recycling. We have to enable and promote the use of digital technologies in the food value chain to increase efficiency in inputs used. This is a fact that has been improving because of the COVID. Our growers are using more and more digital technologies. And additional to biodiversity conservation to maintain soil and water systems health, we have to use beneficial soil microorganisms and the microbiomes for sustainable increases in productivity to face climate change. Thank you.
Thank you very much, Elizabeth. The Q&A session will follow our next presentation, and our panelists will be available at that time. Elizabeth, please be prepared for some lively questions that are likely to come up. So moving on to our final panelist, before we go into the Q&A, we have Dr. Cheryl Hendricks. She is the head of the department and professor of food security at the Department of Agricultural Economics, Extension and Rural Development in the University of Pretoria, where she also serves as director of the Institute for Food, Nutrition and Wellbeing. She is a food security policy expert with extensive experience in policy analysis and program design. She's actively engaged in high-level global food security policy think tanks and panels, as well as being influential in food security and nutrition policy circles in Africa. Dr. Hendricks will present opportunities and challenges for research on food and nutrition security and agriculture in Africa. Dr. Hendricks?
Thank you so much, Jim, and thank you for the opportunity to present this work based on the IAP report. So I'm going to cover two components in this presentation. The first being the IAP report on Africa that I was privileged to lead and to coordinate amongst colleagues from the continent. And that led into the IAP report on the roles of science, technology, and innovation for transforming food systems in Africa. I need to start off by saying that differently to my colleagues who have presented on the challenges in the rest of the world, African food systems are in dire need of transformation. We start from a much lower base, and we start from a system where many of our African food systems are not transformed. And so there are many opportunities, particularly with rapid advancement in population growth, and many technologies that we can gain from in the rest of the world in terms of leapfrogging some of the technological advances from the rest of the world. So Africa is in a very different place to the rest of the world. In some ways, we're far behind. In other ways, we're quite advanced. So Africa's Agenda 2063, which is the African Union's agenda for the continent, which is backed by the 2014 Malabo commitments on the Comprehensive Africa Agricultural Development Program, or CAADP, as it's known, set the stage and also provide a continent-wide commitment to improving agriculture in order to achieve food security and nutrition on the continent. This is supplemented by the Science, Technology and Innovation Strategy for Africa, which sets out many of the priorities, including capacity development for this focus on the continent. Recently, the African countries signed the Africa Continental Free Trade Agreement, which quite interesting advances a number of elements, including intellectual property arrangements around science and technology innovations for improving food systems. So many opportunities and considerable commitment from countries across the continent towards common agreements and common agendas for growth. All of these agreements recognize that agricultural growth is a driver of broad development in Africa. due to the fact that many African countries rely on agriculture, and primarily rain-fed agriculture still, as the source of GDP for the country. Agricultural growth is critical to advance the agenda of the continent. And this has many opportunities for improving nutrition and health, saving lives, and also curbing public expenditure on nutrition-related diseases. That is, only if we get it right. If we follow in the footsteps of much of the rest of the world, we'll have the same problems that other countries, in particularly the North, are experiencing, particularly around overweight and obesity-related non-communicable diseases. So the African food security and nutrition trends are a little bit concerning. We know that the proportion of population that's undernourished in terms of the amount of calories consumed is around 19% of the population. This means more than 250 million people. It's more than double the world average and is up from the 2014 rate of 17.6%. Africa is also home to the highest proportion of hungry people in the world, 29.8% of people in 2019. So if you think 1 in 3 people in Africa is experiencing hunger, and this has increased since 2014. We know that 675 million people in Africa are food insecure. And so we face enormous challenges in terms of lifting people out of poverty and out of malnutrition. Of great concern is the proportion of children who suffer malnutrition. Now we know that malnutrition and stunting, underweight is important and very essential for future development. So we know that undernourished children have major constraints around earning potential in the future. And of course, this has an impact on GDP growth and the capacity of countries as a whole. So it's a very important issue to address, not only at the individual level, but at the household, and also because of the national priorities for improving these situations. So 21.3%, or more than 50 million children, were stunted in 2019. This has reduced slightly since the 2014 numbers, but it's the only region in the world where we have such high numbers of stunting, and this is disproportionately, of course, in poorer households. Child overweight is also increasing in Africa. It was at 5.6% in 2019, up from 5.3% in 2014. And one of the things we're seeing, particularly in North Africa and in Southern Africa, is the concurrence of stunting and child overweight. So in South Africa, for example, which has the highest rate of female overweight in particular, you see stunted and underweight infants, so younger children, living in the same household as overweight and obese mothers. But by the time these children are ready for school, they're also tending towards being overweight. So there's some major problems in our food system. One of them, which I would say, is the over-reliance on the consumption of staples, particularly maize and rice, which is part of an inherited change in our food system from colonial days. Low birth weight is also an issue, although declining a little bit. We still see issues with low birth weight. We know that children who are born with low birth weight struggle in many ways in their early childhood. I mentioned adult obesity. This is also increasing, particularly in more urbanized centers and in the most rapidly advancing countries. So you see it, for example, Egypt, Kenya, South Africa, Malawi, where the numbers of people who are obese is increasing quite dramatically. So these pictures paint the dilemma that we face and depict the problems in the food system. So it's not only about a lack of food, but also a lack of quality food, access to dietary diversity, and the composition of diets, particularly for those who can't afford to diversify their consumption. The causes for this are also quite unique to Africa, and it's a confluence of so many different factors. Economic downturns are one of the big components that have led to major food insecurity and instability in the region. For example, if you take Nigeria, the collapse of the oil prices last year and ongoing conflict in the north part of Nigeria leads a huge pocket of people with major access to food problems. The high level of youth unemployment in Africa is also of major concern. In countries such as Uganda, more than 60% of the population is considered as youth. And of course, that is a major problem. And we also see in terms of youth unemployment that women are particularly disadvantaged. So the prospects of employment for young people in the next few decades is quite dire. So transformation of food systems is one of the ways in which we can look at providing opportunities, not only in agricultural production, which many young people are not interested in. They see it as being trapped in poverty, but in processing, in marketing, in trading, in providing the innovation in the food system, and providing many essential agricultural services. So a great deal of innovation is happening on the African continent in this domain, and young people, as Mohammed showed, are leading some of these innovations. Conflict, protracted instability and violence is one of the mixes in this confluence of factors. Ongoing conflict and prolonged conflict in many countries in Africa have led to a huge number of people suffering in these particular regions. Not only does widespread violence and instability affect those particular countries and the communities, but you also see an overflow of those people into displaced people into neighboring countries, which adds to the existing challenges in many countries facing food insecurity problems in the first place, particularly the DRC, Ethiopia, Kenya, and Sudan. The reliance of African countries, both at the national and at livelihood or household level on agriculture, is one of these factors as well. Not that this is particularly negative, but it does expose many households to the vulnerabilities, particularly of climate change. As mentioned, a large proportion of African agriculture is rain-fed and so is very vulnerable to climate changes. We've seen drops in crop yields due to climate variability. There's increasing desertification, particularly in the Sahel. This also leads to transhumance issues, and particularly amongst pastoralists looking for opportunities for grazing, so leads to conflict. We've also seen widespread drought, and through quite peculiar, very shortened cycles of El Nino and La Nino, particularly in Eastern Africa, where countries have seen successive years of significant climate change in those regions. And extreme weather events you would have seen in the news, the cyclones, for example, that have really hammered Mozambique and left many people without livelihoods and really destroying much of the agricultural potential, as well as infrastructure that links people to market opportunities. So major humanitarian crises, which can't always be predicted in advance, added to already vulnerable situations. Many of these situations also lead to competition for resources. Urbanization also adds to the pressure on land and water and leads to conflict and displacement. And we see this in many of the pastoralist areas as well, where pastoralists are particularly squeezed for access for their nomadic practices. There's also a high level of population growth in Africa. It's still one of the regions where population is growing. And by 2050, Africa's population is predicted to increase by 2.5 times. The demand for cereals is also likely to triple, yet Africa hasn't made huge advances in increasing the productivity of the agricultural system. So there is much to be achieved in many of these areas, and to make sure that we don't degrade environments even more. So increasing population growth, of course, will increase the demand for food, will put more pressure on land, not only for farming, but also for urban settlements. It will affect land prices and is likely to lead to conflict. So the confluence of these factors is quite complex. And although African agricultural growth has accelerated through many innovations, we still lag behind many of the regions of the world. So unlike what Elizabeth was saying in terms of Latin America and the Caribbean being one of the world's largest exporters, Africa is the destination for many imports of food. Countries in West Africa, for example, rely for 40 to 60% of their staple food from imports. So this leads to a significant annual gap in the supply of food. And this is not only limited to cereals, but also dairy, sugar consumption, which is being driven up, and also in the vegetable oil sector. So the over-reliance on imports to meet local demand for staple foods increases the vulnerability of countries to many risks, to insecurities and to uncertainties, particularly as many of the currencies are not stable, and those that are linked to oil as well also have quite significant variability. So while importing stable food is not necessarily negative. For example, countries like the Seychelles, which only has a tiny proportion of arable land, the disproportional reliance on external food supplies does threaten the long-term resilience. And of course, it also drives changes in the food system. World Food Programme, for example, in many areas of Africa, have changed the staple food that they provide in order not to lead to long-term consumption changes away from traditional foods such as sorghum and millet in exchange for maize. So these are important considerations that we have to look at. The aspiration of many young people in Africa is the Western diet, but we all know that it's not really something to be aspired to. We also know that food prices and low incomes, because of high levels of poverty, constrain access to food for many people in Africa, particularly constraining diversity. And this is linked to other elements like, for example, poor electrification levels and not being able to store food through refrigeration, for example. We also know that although the prices do vary across locations and across seasons, perishable and nutrient-dense foods are really much more costly than many of these staples. This is something that skews the diet towards staple consumption. But we also know that these nutrient-dense foods are critical for overcoming undernutrition and micronutrient deficiencies, particularly for children who need to be consuming 5 to 6 small meals a day. But where your fuel and refrigeration opportunities are limited, this becomes very difficult advice to follow for many households in Africa. If we look at the affordability of food, we, from the SOFI report last year, we can see that the affordability of the diet is something quite significant. So relative to the poverty levels, we can see that even on $1 per day, the energy sufficient diet is barely affordable for many people in Africa. And in terms of nutrient adequate diets, the $2.5 per day would barely get you a nutrient adequate diet, and the healthy diet is not available for more than 80% of Africa's population. So we have a long way to go in terms of finding ways of reducing the cost of food without undermining the incomes of farming households, which are the majority of households in Africa. So we know that 3 billion people in the world can't afford a healthy diet. But in Africa, we know that these numbers are quite skewed towards the African population. So 73% of the people in Africa can't afford a healthy diet at 2017 prices. That doesn't take into account the effect of COVID and this mix of contexts in Africa. We know that COVID has caused GDP disruptions for many of the governments in Africa. The shift to providing health benefits and preventative measurements for COVID has meant that many many of the sectors in Africa are affected by these budgetary reallocations. And one of the components that was completely forgotten about African governments at the start of the COVID lockdown periods was how people were going to get food. We know that these lockdowns and their consequences have disrupted livelihoods, meaning that people either can't access their employment opportunities, but also getting food to markets. So some of the work done, for example, by Academia 2063 show that overall in a country, there have been significant disruptions and undermining of the supply of food. But at the same time, we've seen pockets of food systems flourishing at the more local level. So where people are no longer exporting food from a local region, but rather putting it into the smaller community food system. And we've seen some benefits from that, including price benefits. But this has had a bigger effect then on large scale urban populations who rely on the food that comes from those more distributed systems. We know that there have been food system disruptions between these urban and rural communities. For landlocked countries in Africa, which there's a significant number of these, they've been particularly hard hit because of the lockdowns and prevention of trade and supplies of food being able to move, medical supplies being able to move, and also the large number of people actually cross borders in order to access employment opportunities. Price volatility has been one major disruptor, particularly in countries where there's mono-seasonal cropping. So where there are two seasons, it's a little bit more distributed in terms of provisions. It's expected that undernourishment will increase significantly due to the COVID disruptions in Africa, leading to at least 6% more people facing undernourishment by 2030. So in Africa, we're likely to lose a lot of the gains we've made over the CAADP period, and with increasing population sizes, it's not just the percentage that matters, but the number of people that we're actually talking about. COVID has disrupted childcare and schooling. We know that, for example, many mothers are not visiting antenatal classes or child clinics in order to keep up to date with vaccinations. Many governments have not been able to roll out children's vaccination programs, not just for COVID, for very basic things. There are reports that malaria has increased, and we know that many children in Africa rely on school feeding programs, and disruptions to the school program expose children to malnutrition, as well as to many other unfortunate situations where girls in particular are put at risk due to not attending school and having a structured day. Vaccine delivery challenges are something, of course, that Africa is facing, but there are also many beliefs and perceptions that affect change in the health system related to COVID, but also that affect the progression of many of our food systems. So lots and lots of work that has to be effective for African food systems to transform. The will is there, and we can gain from so many science, technology, and innovations, particularly in production systems, as described by my colleagues, including soil quality improvements, innovation in processing and packaging of foods to ensure safer foods and to preserve nutrients, improving health, human health, nutrition, and productivity, addressing fragility and instability, which goes beyond agriculture to the political systems, and also greater access to information and transparent monitoring and evaluation systems. So changes in African food systems have to be supported by a wide range of public and private sector initiatives, including institutional innovation, which I'll speak to in a minute, having clearer food safety and health conscious regulatory environments. We lack a lot, from nutrition labeling to health standards to the capacity to enforce safety regulations on the ground. Greater access to information and transparency is really needed in Africa. But mechanization and digitization can speed up transformation, and there are many examples of this in Africa. So in future, ICT solutions will play a big role in advancing food systems and also being able to address inequalities in the access to information for farmers, for processors, for marketers. Adaptation through sustainable intensification and agricultural diversification, not only of farming, but all farm activities, will be very important to provide the youth with opportunities, but also to strengthen rural-urban linkages. And the financial support of these changes will be essential: microfinance, credits, subsidies, loans, insurances, and perhaps redesigned subsidies for agriculture that could address particular gaps in the food system. In terms of innovations around institutional components, which is actually my passion as a policy analyst, I just give a brief insight into how Africa has used these institutional advancements to manage malnutrition in particular. So the countries displayed in this slide are the 7 countries who, over the MDG period from 2000 to 2016, made the greatest dents on child malnutrition. On the global food security, I'm getting it all wrong, in terms of the International Food Policy Research Institute's Global Hunger Index. So Senegal led the pack of reducing the global hunger index for the country by 56%. Ghana by 54%, Rwanda by 53%. Some of the stars we know in the African development context. But you might be surprised to see Angola and Cameroon listed amongst the top achievers for reducing the global hunger index. And this was mostly due to multi-sectoral approaches to coordination of nutrition interventions in the countries. So these countries made nutrition a priority. There was private sector involvement. There was a big focus on children and localized ownership. So mobilization of communities in order to take control of the local food systems, the health systems, and to help spread the information about how to improve these conditions at the local level. So just some examples of how leadership and coordination of institutional efforts makes a big difference and is one of the critical components to complement science, technology, and innovation changes to support food systems. So in concluding, I firmly believe that science, technology, and innovation can overcome the challenges and transform African food systems to achieve the African Agenda of 2063, which is encapsulated in the Africa we want, and to achieve the SDGs through bold actions that African governments will take through the Food Systems Summit. Thank you so much.
Thank you very much, Cheryl, for the excellent presentation. Now I'm going to ask the 3 remaining panelists, because I see that Mohammed Hassan has in fact dropped off. Please turn on your videos and your audio while we maneuver ourselves through some of the questions that we have. And so we've received some wonderful questions. And what I would ask is that we try and keep the answers brief and succinct. The questions that have come in have not been for specific panelists, but if you feel particularly equipped to answer a question, and then please do so, and then others can, of course, add to that. So I'm going to go ahead and start with one of the questions that came in early, very early on, into the Q&A session. So please, if you have questions, don't forget to add them through the Q&A function that is right down at the bottom of your screen, right next to the raise your hand function. I'm asking that you use the Q&A function for your questions. So this question that has come in from Noor Iraqi from Morocco, and I apologize to you, Noor, in advance. I have reorganized your question. So here's how I understood it. These innovations are always disruptive. Customers, businesses, and governments are often slow to accept these changes. How can we prove that they're both for the greater good and good for the bottom line for these companies? Anyone want to take that one?
I can have a go if you wish.
Yeah,
Some
please
recent
do.
work that we've done for the Food Systems Summit Science Group on the true cost of food is one way in which we can do this. So estimating what these changes to improving the sustainability and healthiness of the food system will do, and what they will do to reduce the costs for future generations, as well as to the health environment and the health sector now. So some of this is not necessarily looking at intervention level, but perhaps at the broader system and what some of those incentives for action could do. So I'll give you one example. For example, we know that fair trade bananas are more pricey to buy in the foods on the shelf than non-fair trade bananas. But actually the fair trade movement have internalized many of those production problems and made production quite efficient, to the point that producing a box of fair trade bananas is actually cheaper than doing it in conventional ways. But the gap then comes between production and what you see as the price on the shelf. So the price premium is not at the production level, it's actually a saving at the production level, but a price premium paid by the consumer for the brand.
Thank you, Cheryl. Robin or Elizabeth?
Yeah. Might I just add something to answer about innovations always being disruptive? And in a sense, that's a problem that characterized Europe in many ways. And I'll come back to GMOs. Because the view quite often from our policymakers is that they have to conform to the precautionary principle. That is, don't risk any harm or disruption. And if there is a risk of doing that, then do nothing. But of course, the comparison isn't made in policy terms with the risk of not introducing that innovation. So, and this is a classic example illustrated by the problems that we've experienced in Europe on GMOs and now genome editing. There is a fear of doing anything because of the potential hypothetical risk to health and the environment. So the easy option for a policymaker is to do nothing. But of course, if you pursue that approach, then you don't gain the benefits through innovation. You don't gain the benefits, competitiveness and profit, as the questioner asks, and you don't improve the you don't deliver the societal benefits that may accrue from the innovation. So I think one has to recognize that, yes, innovation can be disruptive. That is not an excuse not to pursue the science. I think we should always pursue the scientific opportunity to see where they lead. And then, of course, that there are public policy decisions to be made based on the choice of converting that science into innovation and practice. But unfortunately, some policymakers are very fearful of any risk.
Okay, well, thank you, Robin. There is a related question, but Elizabeth, you want to go ahead and
Yes.
give your
Again,
input, please.
I'll try to be very, very short. The thing is, of course, innovation most of the times is disruptive, but the main thing for food systems is that innovation should articulate with local conditions and should integrate with local knowledge, because all the decisions must be bottom up. The communities are the ones to decide because they know their conditions, their resources, their cultures, and that is the way. Thank you.
Yeah, thank you, Elizabeth. A very, very important point. And this next question is actually related to that. It's from my colleague, Dr. Joel Cuello, here at the University of Arizona. And it came into the Q&A function. So I'm encouraging you to use that, folks. And to your point, Elizabeth, recognizing that all places have innovation. But given that some are more innovation rich than others. And so Dr. Cuello's question is, innovation relating to the food systems is exponentially advancing, that there are clear risks that there will be a widening gap between the innovation rich and the innovation poor countries in regards to food security. And what are, to your knowledge, what are some of the regional and international organizations doing in terms of programs to alleviate this growing situation? The question is for everyone. Anyone would like to take a first shot?
Yeah, a very short one. I would say the CGRs are working a lot on this. For example, in Latin America, the Alliance Biodiversity CIAT is working a lot on this, and they are working very hard, like in gene editing for very important traits in the local crops. So yeah, there are several international agencies working on this.
Thank you. Robin or Cheryl?
Well, let me just say that although the situation in Europe, where I'm based, maybe rather different, we do certainly have regional initiatives through the EU to share research and to share the conversion of that research into innovation and to share the good practice that arises. So to some extent, yes, there are initiatives to address what might be a widening gap otherwise. I think perhaps closer to home, the academies themselves have a great role to play in sharing good practice, sharing information and knowledge with other academies and with other stakeholders. They can take a leadership role in the scientific community to work with others to narrow the gaps, both on the basis of the current science that can be used, but also to identify where there are gaps in the knowledge, not just gaps in implementation, but knowledge gaps that can be filled by new research. So certainly the academies have some key roles there.
Yeah, thank you, Robin. Should I move on to another question, Cheryl, or did you want to add something? Okay, and just as a reminder, Dr. Cuello, who asked the question, will be a panelist on Friday, so he may have given you a sneak peek of what he's going to be talking about by that question. I have a question while we're, and in fact, let's see, maybe this one and one other before we wrap up. It's been an exciting 2 hours, and I don't want to keep either our panelists or our participants much longer. It's been very, very interesting. My question is, what do you see as the role of halophytes like Salicornia as potential sources of food to address food shortages around the planet, especially in places like Pakistan, where a large fraction of what used to be arable land is now saline. And so there are saline friendly halophytes who can be grown in there. And those, the reason I asked the question is because the most useful of these are in fact GMO. are modified seeds to provide flavor, to provide nutrition, to provide additional calories. And so I'm wondering if you have a general sense of whether or not that is an avenue we as scientists ought to go down, or perhaps not.
Well, I mean, I just comment that I'm not familiar with a particular background, but clearly science can help to provide solutions to cope with new challenges, whether that is the impacts of climate change or land degradation and so on, which is not to say that we shouldn't also do all we can to conserve natural resources and the quality of a land. And Elizabeth, for example, has talked about the soil microbiome. But yes, I think there are opportunities through improved crop and improved animal breeding programs to respond to some of those severe challenges that we're increasingly facing. Again, in Europe, there are many activists and public groups, who would like to turn the clock back. Essentially, I mean, talking of nature-based solutions and all these are part of the agronomic mix. But essentially, we do face challenges, and I would certainly argue that we do need to empower our science to develop new breeding programs that may be more suitable for degraded land or drought conditions or whatever.
Thank you, Robin. Elizabeth or Cheryl?
Yes, I think it depends on the specific case, but science and technology, as Robin said, can help a lot. It's better to do preventive things. That was why I was talking about to maintaining the health of soils and waters, because those are the basis for agricultural production. And if we have to restore things, we have to use the microorganisms, which are so potent, they are so good, and they are so adapted. They teach us so many lessons. So it depends, but yes, science and technology can help to many, many situations. But it depends, and we have to use it very, very wisely. Thanks.
Thank you. Well, I'm going to, if you don't mind, Cheryl, I'm just going to move on to the last question. I'm going to lump two of them together. They both have to do with financing. One is a question about what kind of major funding has been put in place in any of these programs. You've shed some light on some of the challenges and potential solutions. How are they going to get paid for? And if the answer is yes, have we seen results? And then tied to that, it's actually the financial sector buy-in. So I would say there is the financial sector that is governmental, and then our intergovernmental international financial sector, aid agencies and the UN and such, but also private financial sector. And the question is, I guess it says climate change doesn't wait for proof. How long will it take to get the financial sector's buy-in? Anyone want to take a shot at either one of the two kinds of questions? What kind of finances have been put on the table? And if significant funding have there been results that we can point to as examples of success?
Well, as you know, at the moment, much of the funding is diverted into COVID. So sadly, we may lose a lot of agricultural funding, but banks and lending institutions and certainly our insurers are starting to move in this way. And the game is changing, particularly with changing accounting systems and looking at how you value the costs, particularly of externalities and of the hidden costs for the environment. And so these kind of elements are now being built into some of the funding mechanisms by major banks. So there's a global move towards some of these happening at the more global infrastructure level. but still we need much more on the ground that would create incentives and appropriate incentives for farmers, particularly at the small scale level in Africa.
Thank you, Cheryl. Elizabeth or Robin?
Well, perhaps if I just add to that, first and foremost, I think the forthcoming UN Food System Summit, is a great way of creating a visibility of the need for funding and to develop the momentum across a number of sectors. It's not just the tradition, as it were, the traditional funders of agriculture, whether in the public sector or NGOs. We do need a cross-sectoral approach, and the summit is a good way of bringing those voices together. So secondly, if we're talking about funding, we do need to keep making the case to invest in science, including fundamental research. If we don't invest in basic sciences, then we lose the resource for future innovation. And thirdly, perhaps shouldn't end on a negative point, but thirdly, historically in an area like Europe, that there was a lot of money going from venture capital companies into the startup sector in biotechnology and other technologies. And that still carries on, but it shifted. Essentially, all of the venture capital biotech money now goes into the health sector. It used to go in partly into the agriculture sector. It doesn't anymore. And that's a direct consequence of the antiquated regulatory system that we have in Europe, that there is no profitability. And that may be a cautionary lesson for others. Don't make that mistake.
Well, perhaps, Robin, as we move, we ought to be convincing that investing in what we put in our bodies might also be an investment in our health. So with that, I'm going to just go ahead and wrap things up, if you don't mind. I'm going to, first of all, thank you as panelists, Mohammed Hassan, who is no longer on this panel because he had to step off, started things off. Robin Fears, thank you for your presentation. Elizabeth Hudson and Cheryl Hendricks, thank you. Also, I'd like to thank the organizers, Dr. Cherry Murray, who served as our esteemed chair, Dean David Hahn, who was our host. And then in the background, Dr. Hassan Bafai, Dr. Brian Topping, Jennifer Krause, and David Hostetler. And I'll end with a reminder that on Friday at this same time from 9 to 11 Pacific time in the US, we will have the second of these panelists, or these panels, a webinar that'll be focused on primarily on solutions. With that, I'm going to go ahead and close and thank all of you who participated as participants from many, many parts of the world. Thank you very much.